one. Okay, so what we need to be able to do, and by the way, like when you go back and watch these videos, I can almost guarantee you every single video is going to start with me saying so. I don't know why I can't control it. I apologize. We need to disconnect these pieces. I want to make things that are adjacent but separate. For the purposes of this project, simply so that I can separate them and print them as different pieces so I can put them back together. I might not want to print those 4 walls all as one single piece. Okay? So how I'm going to set this up, actually, is I want to print those 3 walls as one piece, this center wall as a second piece, and I want to be able to lock those 2 together, right? Sort of have a notch where they can slip together. Cool? So to do that, what I'm going to do is, first of all, I don't know what I'm doing. I think I'm just going to delete this guy, right? So I'm just going to select and delete. I'm good with making new stuff. There's probably different ways to do, well, not probably. There's always different ways to do different things. Okay? So you can see I've got this, and I'm down to this piece with a hole in that wall. Okay? Now, when you have situations like this, super easy to repair, right? So I've got this gap. Oh, and remember, we talked about this last time, but I need to turn on Watertight. Okay, so let's review that again really quick. That's under Window and Visual Styles. Make sure that that's checked. And you're going to go to your wrench and identify watertight issues. You should all be looking at this saying there's going to be a huge watertight issue right there. And watertight is exactly what it says, you guys. Will it hold water? That's all you have to think about with watertight. Will it hold water? And clearly, that is a great big gaping hole. Right? Oh, all the way across the bottom too. Right? So as soon as I turn on watertight, I should have lots of red lines. For this project, since our output is 3D printing, you should just be working with watertight checked. I want to be able to see where those errors are going to happen. Right? So that way, when you get to this point, you can fix them quickly. So to fix this, it's simply a matter of replacing that geometry. So one line right there, single line, got rid of all of those watertight issues. Right? Because that's all that it needed. So I'm going to do the same thing here. One line across the base, here to here. Should do the exact same thing and fix all my watertight issues on that side. So essentially I've got 2 walls, right? Ready to go. But I want to make a little bit of a centerpiece here. So those that next wall will kind of piece together like that. I want them to be able to lock together. So to do that, I'm simply going to come in. Let's draw that as a 3-pointed square or a 3 vertices square. 1, 2, 3. Gives me another watertight issue there because that is not a 3D piece of geometry. It's a 2D piece of geometry. But I'm going to go ahead and pull that up 6 feet. Seems like fun. And now that is, again, it's watertight. And now it's all the way back to one single piece. Cool? So, if my next piece that I'm fitting, that I'm going to design to fit there, if I don't want it to stick to that, if I want it to be a separate object, so I can move them apart and work with them separately, I need to group these. Okay, so with all of it selected, so that's a double click, or I could do a great big lasso, right? Double click or a lasso. Usually it's a double click. Because in particular, the double click is going to show you, oh, everything's connected. Lasso might pick things that aren't connected. Okay, so double click, select everything. I'm going to right click. Again, that's my shortcut menu. And right here, these 2 little objects say create group. So I'm going to do that. And you can see it puts this little dashed bounding box around everything. Now, I'm not clicking a surface anymore. When I left click once, I'm selecting everybody. So with one click, I'm selecting everybody. With my next click, I can move everything around as a group. When I want to edit that group, I'm going to select it, then double click. And you can see it fades everything in the background away. And now I'm back into this acting like a normal set of objects. Okay, so if I back out of that, right, and I did that, I just clicked in the open space to back out of that. If I make something on this wall now, so I'm going to go line tool, I can still select that edge. Let's close that up as a piece of geometry. Let's sweep this up. If I double click this now, it does not select everything because that is its own object. Alrighty, so let's delete that. Let's remake this center wall here with that kind of method. So to do that, I'm going to create a sacrificial line first. Well, I guess it's not going to be sacrificial. Actually, I need that line. So I'm going to go down 6 feet. So I'm starting at that corner. I'm coming down 6 feet. I am coming out and away along the green axis. I'm going to do the same thing across here. So line, line, line. I'm going to pick up my red axis again. I'm going to use Shift. And then I'm going to left click to get my inference. And then close that up. And I need to do one more line right across here to build that object. And then I can sweep this dude up. Then I should be able to sweep this dude out. Then I should be able to sweep this piece down. Now, do you guys notice what it did right here? Okay, do you see how I don't have a line right here? Okay, also, do you see this weird flickering? Oh, come on, do the flickering thing. That weird pattern right here. If I navigate around, you'll sort of, a lot of times it goes complete disco ball, it'll like flicker and flash. That is when you have two coplanar pieces of geometry. Super common problem that you're going to have working in 3D space. Essentially, I've got two objects, same place, same time. The computer does not know which one to display, so it gives you a crazy flickering of both. Sometimes it's not a big issue. Like Revit is going to do that constantly. If you think about a wall and a window, you're going to have the edge of the window, the edge of the wall as two coplanar pieces of geometry. But that's rarely going to matter in terms of what you're displaying, what you're rendering. But in this situation, matters a lot. For starters, I get this really weird line that dies into nothing. Right? That's because this wall shape is actually coming all the way down and over to here. That shape is not built correctly. So, for instance, if I take this guy, and let's just move it out. Say I don't have that cut. Okay, so let's rebuild that wall just a little bit. I'm going to do an undo back to here. And I am going to create a line right here on that object. Then when I sweep that down, I'm going to see that line. Cool? Super, super important to kind of keep your eye on that. And I still have a red line right here, which is kind of fun. And I should just be able to delete those extra lines because they're not totally needed. And I should even be able to delete this set of lines as well. Although I'm breaking stuff. Oh dear. Okay. FormIt is going to zoom relative to your objects. Can anybody tell where I'm at right now? I'm stuck in a wall. Okay. And this is actually, again, this is not a fault. This is a feature. every time my mouse clicks forward, it is going to zoom based off of the level of detail, how much information, how far away something is. So that when I'm working on a full building or a city, right, if I'm zoomed way out, bird's eye view, as I'm rolling that mouse in, it's going to move me faster. If I'm working on a column on a building inside of that same city, when I roll the mouse, it's going to zoom slower. So on occasion, you're going to find yourself stuck in a wall like this. Whereas, okay, and so kind of watch this. See how it's zooming here? If I go over here, further away from the wall, so it zooms faster. On occasion, you can get really stuck. Okay, so what I'm going to do, let's just see if I can't get back into the wall. Right-click, and I believe in here is zoom to fit. Ungroup all, rotate, scale. Oh, it's not in here. So I guess it's this one right here on your list. This is zoom extents, and it will snap you out of things. Okay, so you guys see what I clicked right there? Zoom extents. Okay, let's see what kind of mess I've made here. Okay, so see that big red line? Pop quiz. What line am I missing? What's going to fix all of that? You guys can see what face I'm missing, right? Where it's not watertight. Right? I'm missing this entire face. You want to get good at this geometry game and understanding what line am I missing that's going to fix all of that. It's that little line right there. Should fix all of it. Okay, so let me just zoom in. Line tool, line, that edge to that edge. I still am missing a piece of geometry right there. See, I'm still missing that. And so that's going to be this line right here. I am now watertight, good to go. Also, I can take this now, and that's its own dude. Dude being a non-gender specific term, as is guys. Please understand I'm an Ozarkian person, and I can't help it. Okay? With me? That's a tricky little thing to get used to, the sort of grouping and keeping things from sticking together. If you'll start it on a simple project like this, it will help you if you're taking FormIt into more complicated groups or more complicated objects. And it's the exact same thing if you're going into an office that uses SketchUp, which many of you will. SketchUp is super popular. It functions the exact same way. It uses the exact same mode of thinking in terms of grouping and in terms of things kind of being sticky. You draw something on something else and they are merged. Revit does not do that at all. You don't have to worry about it. But again, it's a feature. It's going to help you keep things organized. Okay, so one more quick review with the 3D printer. Never mind. I'll talk about that when we do the 3D printing. I was going to build some guides to create the little niches in this wall, but not going to do it. Okay, so I'm ready to send this thing to the 3D printer. Now, I want these 3 walls printed out as a unit. This one printed out separately as its own unit. So right away, I know I need to separate those pieces. Okay? So I'm going to double click that, and I'm going to move it away from the other objects. Right? So those are now 4 separate walls. This niche, or this little notch, I should call it, not a niche, and this notch are the exact same size, which should probably concern me a little bit. Right? It's kind of like if you drill an 1/8-inch hole and try and put an 1/8-inch peg into the 1/8-inch hole, it won't work. Right? I should have the same problem, but again, it's a really good starting point for me, so I don't care. Right? Those are the types of things you're going to have to adjust on your second and third passes. So, the 3D printers, the process is we are going to send it, no different than when you're like in Word, you go File, Print, and it pulls up your print driver. And with your print driver, you can say, I want this many copies at this scale, and yes, please collate, all that stuff. The Prusa slicer is essentially the print drivers. That's what we're going to be working with. Okay? To get this into our print driver, which is Prusa Slicer. We need to save it as the right 3D format, which is going to be stereolithography. It takes a couple of different file types as we get into some more advanced printer stuff. As we get more advanced printers, we'll start doing OBJ files as well. But for now, we're doing stereolithography, which is .stl. So what I'm going to do, bless you, I'm going to go File, Export, Locally. I'm going to scroll down and select STL. Now, if you notice, I have options here. So if I have hidden objects, something like that, in my scene or hidden layers, I can select only the objects that I want to. But in this case, I'm going to do all of my objects. So this is all objects and export. And then I'm going to give this a name. Just going to send it straight to my desktop. ARC 222 FormIt Modeling Section 1. Oops. Oh dear. Click something wrong in there. Section 1. Save. Cool. Easy peasy. Then I'm going to launch Prusa Slicer. Okay. So if it's the first time that you have loaded up the Prusa Slicer, there are about, I think there's like 8 different flavors of Prusa printers. And we have to select the correct Prusa, the Prusas that we have. So to do that, we are going to go to Configuration and Configuration Wizard. If it's your first time to launch Prusa Slicer, it should automatically take you to that. Okay, if you're looking at it right now, if you've got Prusa Slicer open, and it doesn't, then you can go Configuration and Configuration Wizard. So here's the welcome screen. That's all good. I'm going to go next. We are the original Prusa i3 MK3, not the MMU2. We are the original Prusa i3 MK2S. This is us right here. We have the default nozzle, 0.4 millimeters. Just double check and make sure that's right. Yep, that's right. Okay, so that's the one. I'm going to click Next. When I mentioned printing with liquid resin, those are Prusa's liquid resin printers. That's where all this stuff is probably headed, right? Eventually. It's not going to be by the time you graduate from here, but probably what you'll see in your office is one of these because, again, we can move light a lot faster than melted plastic, right? Next. These are your filaments. Oh, no, these aren't filaments. These are other 3D printers. We don't care about those. Right? If you'll notice, Lulzbot is in here. We used to have those. Oh, we have them offline right now. So, there's no reason to even, you could essentially use Prusa Slicer to send something to a Lulzbot. All right, but yeah, you don't need to worry about that. So we're just going to go next again. We're not going to create custom profiles. We're going to use their defaults. This is your filament types, okay? We use PLA as our primary filament. On occasion, we use PETG because it is UV resistant. So things that we're printing that we know are going to go outside, we use the PETG stuff for. But it's a little bit more finicky. It's less fun. PLA is, first of all, it's sort of the standard for 3D printing, PLA and ABS. ABS is oil-based. PLA is corn-based. So you can tell right away, one of the reasons why we prefer PLA. ABS is a little more flexible when it prints. It's going to last a little bit longer. PLA is a little bit more brittle. So if you're engineering parts, sprockets, things like that, maybe ABS is a little bit better. because PLA is a little bit more brittle, but we don't care. So PLA is better for us. PLA biodegrades. So it's not that you shouldn't feel guilt about throwing it in the trash can. You probably should, but it at least will biodegrade and go into the earth and eventually become corn again, right? ABS, you throw it in the trash, it's going to be in the trash and then in the landfill for the next, 400 years. So PLA is definitely the material of choice for us, okay? It's not that we don't print ABS or PETG or some other things on occasion. But also, if you flip through here, there's some really cool stuff, including filament that has carbon fiber. If you're trying to print something super, super strong, there is filament that is conductive. So in other words, you can hook two ends of it to a battery and another end to a light bulb, and it will light something up. So there's all kinds of cool stuff that's out there. But for the most part, we're using PLA. So let's go ahead and click next to that. And then your configuration, do you want it to automatically update? Sure. All that stuff. I think that's the last one. Path names, that's all good. Files associated. 3MF. 3MF is when you save something out of Prusa, it's going to create a .3MF file. That's Prusa's native file. And then STL files, I'm going to check that. Because if I double click on an STL file, I want it to open in Prusa Slicer. Cool, so I'm going to click next there. View mode, yes, we usually want expert because we make some changes to keep things printing fast, so expert's nice. And then finish. Okay? All right, so what this is the plate that you print on. It is a virtual reconstruction of the plate. It's not very big. Right? 1-to-1 scale. So we were working 1-to-1 scale, and that's 7 inches by 8 inches, 7 inches by 6 inches, something like that. I'm not sure. I should know. I don't. It's probably because it's in centimeters. But this is a 1-to-1 recreation. Problem. How big are we in FormIt here? Measure. Out to out. 57 feet. That is slightly larger than this. Right? So when I import that in, File, Import, STL. I save that to my desktop. Import, FormIt modeling section 1.stl. Open. It should have been huge. If you already know the answer, you don't get to answer. If you have no idea, like if you didn't have me for studio last semester, what just happened? Why is that so much smaller? Mark, why is it smaller? It's a good question. There is the possibility that the software took control and said, you're an idiot. This isn't 57 feet. It's 5 inches. Deal with it. And some slicers will do that. Usually they let you know. However, for us as architects, that would be a huge problem because scale matters, right? Especially if we're running 3 or 4 different prints and we need to put them together later. Excellent guess, but wrong. Okay, when we talked XYZ Cartesian coordinate axis system, remember I was talking that, that's what defines our 3D, right? So 0, 0, 0 is your axis. That's your center point. 1, 1, 1 would be over 1, up 1, right? The computer doesn't think in feet, inches, centimeters, meters. It only thinks in numbers. The software is going to interpret the numbers for you, right? So inside of FormIt is thinking in feet. 1, 1, 1 equals a foot over, and a foot up. Prusa Slicer thinks in millimeters. 1 millimeter over, 1 millimeter over, 1 millimeter up. So we have officially shrunk everything down by a factor of feet to millimeters. So it comes in much smaller, which is cool but kind of annoying, right? So I know I want this to print out at an architectural scale. And let's guess it's going to be 1/8 inch. So I have to do some math, a lot of math. Not really a lot of math, but for us in architecture school, a lot of math. So I got really annoyed of doing that math over and over and over again. So I created an Excel spreadsheet to do that for you guys. It is called the scale calculator. Where did it go? Oh, drat. Scale calculator. There it is. Scale calculator. Now, this is a use at your own risk tool. Please leverage some common sense when you use this. Right? Know what numbers you're putting in. That's all I'm saying. Okay? But how this works. First column, 1 inch equals some kind of feet. So if I do 1 inch equals 16 feet, what would my scale be? Architectural scale. It's not that early, you guys. 1 inch equals 16 feet would be, said so shyly, 16th inch scale. Uh-oh, what did I do? Okay. If I wanted this to be 1 inch, an 1/8 inch scale, what would I type in? What? 8. Super easy, right? I don't like complicated. 1 inch equals 8 feet. You see how it updated all my rows? So that is, the first number is our scale factor. If I just had 1-to-1 and I needed to shrink something down, right? I take HSA and I want HSA at an 1/8 inch. I would multiply it by a factor of 0.0104125. Okay, that's the scale factor that I'd be shrinking HSA down by. 1.04125%. So that's the first number. And if you look at that calculation, it is 1 over A2, so 1/8 inch, times a 12th, 0.08333. If I take 1 divided by 12, it's 0.08333. Cool? Because I've got to keep my units the same. If I want an 1/8 inch scale model, the next thing that I have to do is convert this, B2, to feet to millimeters, which is a scale factor of 304.8. And that creates that. As we've needed additional things, I have continued to kind of work through and add stuff to it. Illustrator works in picas or picas. 3D Studio Max works in inches, not feet, which is super annoying. If I input a number, like 10 feet, this will give me incremental out, same scale factor. Okay, so this is available to you guys as of right now. Save as, browse, DU storage, architecture classes. Wow, network is slow. Come on, architecture classes. It's thinking about it. There we go. Architecture classes, 222. Uh-oh. Those are last semester's classes. Let's do a new folder. I hope you guys will all be able to see it. 222-22 beach. Save. Okay. Somebody here take a second and see if they can find that while I continue on. If you can't open up that folder because of privileges or something like that, let me know. But that's where you'll want to find that. And go ahead and copy it to your computer. You'll use it just about every time you send something to the 3D printer. Okay? So from here, this is the number that's important. 317.37. right? That's the scale factor that I need to increase by, bless you, whenever I create my final print in the Prusa. So let's go back to Prusa Slicer right here. So with my object selected, okay. Oh, and let's do this really quick. Wheel, zooms in and out. Hold the wheel down, pans. Slightly different configuration. Left is going to orbit. Okay. So just one of those things you have to get used to how each piece of software sort of handles its navigation. So what I'm going to do from here, I'm going to select my object. And right over here on the right is my scale factor. Right, so I'm at 100, 100, and 100, X, Y, and Z. All of those are locked together. So in other words, I'm going to scale X, Y, and Z at the same time just by inputting one number. That's what this little lock symbol means. So I need that to be 317.37. 317.37. Enter. Cool. And I can look at this at this point and say, oh, that's bigger than a toy. Bigger than a Lego. Way bigger than a Lego. Right? Fits. So that's a plus. But my guess is that's going to take about 8 hours to print. So to find out how long it's going to take to print, so I already know it's too big, but I've already said it, so I want to guess. I'm going to do slice now, and we'll see how long it takes to print. 8 hours and 5 minutes. Man, I was close. That was a really good guess, Dave. Well done. So that's no good. It's no good because it's too big. No good because it's 8 hours to print. No fun, okay? We'll go back through that in just a second. Let's go back to my scale calculator, and let's drop that by 50%. So 1 inch equals 16 feet, 158.69. It's my new scale factor. Prusa slicer, 158.69. Enter. Yeah, much happier with that size. And this is at an 1/8 inch. Now, I mean, in other words, I can take a scale to it, and I know when that prints out, I'm going to get 57 feet across at an 1/8 inch scale. Right? So it's super important to do this. We're always working at a scale. So once I'm happy with the size of my object, I'm going to officially run the slicer. Couple of things to note. Print settings. Right here. If I click, or if I look at these three pieces, I want to set this to 0.20, so 0.2 millimeters normal. Okay? That is typically how I'm going to configure this. Right? So 0.2 millimeters normal. What that means is, okay, so 3D printing is essentially 2D printing over and over and over again. So the 3D printer is going to trace a line on the border of my objects and then do an infill between the borders over and over and over again. And it's going to stack them up. So it's doing a two-dimensional line drawing at 0.2 millimeters thick over and over and over again to complete the entire object. Okay, so really just think about it. It's slicing, it's doing 2D prints over and over. They even make a 3D printer that uses paper. Okay, it slices the paper, stacks it. Slices the paper, stacks it, and glues it. Which sounds stupid, but then the interesting thing about that is then you can print each layer of paper and you can get a full color 3D print. But they're stupid expensive and they break all the time, so we don't have them. Okay, and if you think about how much paper that wastes, I mean, you're essentially putting in reams of paper and it's throwing away, like on this, it would be throwing away an entire ream of paper to go about halfway up this. So yeah, we're like, no, we're not getting those. And they break all the time. But there's a lot of different things that you can do with these, okay? So I'm doing 0.2 normal. Generic PLA, we're typically fine with that. So PLA, what that's going to do is that's going to set a temperature for the print bed, this surface, so that it sticks. And it's going to set a temperature for the nozzle. So a 3D printer, the ones that we use, it's a hot glue gun, essentially, connected to a robotic arm. And you can think of it as squeezing out the hot glue, the filament being the hot glue. That's essentially what they are, right? But we've got to tell it the temperature, essentially to plasticize the PLA, right? Different materials, different temperatures. So we're going to use generic PLA, and then that is my printer, the original Prusa i3 MK2S. Infill. This is what's happening inside of your pieces. If I am making a gear, a servo, or something that I want to throw across the room and it not break, I might need to increase that. 100 would be printing it out as a solid object. If you think about that, that means much more filament, much more time, more costly. The default is 15%. Almost everything for architecture is totally fine at a 5% infill. We do need a little bit of infill, right, to make them strong enough, but we're not chucking our models across the hall and expecting them to not break. And, well, technically, 5% infill, you can chuck it across the hall, it's still not going to break. Okay? So 5%, it's less filament, it's going to print faster. What else? Oh, that's really it. So then I'm going to click the Slice Now button. I'm going to guess this is a 3-hour print, something like that. Right? So if I scroll down, I can see this. Oh, 1 hour and 47 minutes. That's not so bad. Totally doable. If you notice, it have 2 buttons now at the bottom. That's my solid. That's my stack. I have this slider right here. This is each layer. Right? So it starts right here at the 0. And you can see 0.2 millimeters right here. This is each layer that it's going to print. Okay, so if you'll notice, it's starting right down here at the bottom. Oops, pull that all the way down. That's the first layer. When we are 3D printing, that first layer is the most important thing. You are not allowed to go into the I/O, hit print, and walk away. You're always to stay to the first several layers. If there's nobody in the I/O, you are to stay for the entire print. Okay? But it is required of you to stay at least through, let's say, something about like this, your first couple of layers. Because when these fail, usually they fail in these first couple of layers. If this base isn't right, when it gets up to here, it's not going to print right either. Okay? Now, gravity works, right? So when I have something like this, an opening, there is the chance that this layer right here, as the print head is coming across this, I might get a little bit of a drape right here. But as long as I'm not trying to do something that's like 4 or 5 inches, totally fine. 2 inches is about the maximum that we like to go, right? And what you're going to see is the plastic goes across, it's just going to kind of go bloop, but not so bad. And you can take your hot glue gun or something later and just kind of smoosh it back up, or like not care a whole lot, because it's usually not too noticeable. But if it gets too big, it's going to fail. You're going to get like this little gross thing. This exposed edge right here, a little bit more complicated because it's not bridging across. But even that's so small, I would say I give it a shot, see what happens. Right? It's not going to cause a massive print failure. So you can see my infill is this dark sort of maroon. My outside is the orange. My fill on the top, the finish layer, is red. Bridging locations, those are blue. And that zips all the way up. You can do things at an angle, at about a 30-degree slope, all the way like this. Because again, if you think about it, it's putting down the plastic as steps. And it will step out and cantilever really, really well. Right? So there is a lot that you can do with this. I always encourage you guys, let it print, see what happens. On the rare occasion that we need to, we can turn on supports. And there are several options. Supports on the build plate only. Supports for enforcers only. I have no idea what that means, actually. I'll have to look that up. Or supports for everywhere. Right now, if I did supports on the build plate only and did Slice Now, The only place you're going to see supports show up is right here. So let's look at what happened with that. It's building a support for that little bridge. These openings right here and right here do not go down to the build plate. So it's not going to build supports for them. Okay? If I do supports everywhere and slice now, it's going to give me supports everywhere. And the idea, the goal behind these supports is after the print is done, I can snap them out. And usually they work pretty well, especially if you get your print quickly. The longer it sits, the more the plastic cures, the more difficult those are to snap out. If you can see the additional print time, it really didn't add too much. It went from 1:47 to 2 hours and 3 minutes. That's not so bad. But experience tells me I don't need them. Cool? And you're going to get used to that. I'm going to need supports for this. I don't need supports for that. Pretty easy to work through and figure out. Right? That's it for the day, y'all. I gave you absolutely zero time to work. I apologize. But lots to cover. Friday will definitely be a work day. We'll take those of you who have not used the 3D printer into the I/O and get you pushing buttons.